This video is on the objective, use the law of cosines to solve SAS triangles. Right, those are side angle side triangles. So triangles in which you know two side lengths and their included angle, right, the angle they form, the angle between them. You know all those things. And then you're asked to find, the missing pieces, the one missing side and the two missing angles. And this will be using the law of cosines. Alright, so again, if you want to see more about the topic, click on More Instruction, look at their videos, their notes, their examples, and hopefully those help you. Alright, so I'm going to draw a picture of this triangle here, and we're going to find, missing side little b, and the missing angles, A and C. Alright, so again, we have an SAS triangle, and in the SAS, right, side angle side, or the SSS, right, side 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 triangles, you can solve them using the law of cosines. Two sides and the angle between them. Okay, so in the side angle side case like this, the only thing you're going to be able to find using the law of cosines is the side opposite the angle you know. So I have to find little b. Alright, and I'll start with little b squared, since I know angle b, is equal to a squared plus c squared, right, the sum of the other two squares, but then some more, minus, and then twice the product of the other two sides, 2ac, times the cosine of angle b. If I start with little b squared over here, there's angle b in the cosine over here. And this is all one term, right? 2 times a times c times this cosine of angle b. And just fill in some missing pieces. Now again, I know everything over here. So to find side b, I would just need to take the square root, right? We'd have b squared equals 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of this 106 degrees. Now I can type all that in if I want the way it looks. I'll simplify some things here just so I have less typing to do. 4 squared is 16. 6 squared is 36. 36 plus 16 is 52. And then this product here, 2 times 4 times 6, that's 48 times the cosine of 106. Now again, be careful. I think I mentioned this in the first video as well. Don't put these together. Don't put 52 minus 48. Don't say that that's 4 times the cosine of 106. This 48 is attached to the cosine of 106. So you can't subtract it from the 52. Alright, so then b, that's what b squared is. So b is plus or minus the square root of this, right? Now, again, since it's the side length of a triangle, I'm just going to look at the positive square root. And this is what I'll type. Okay, and make sure I'm in degree mode here as well when I pull my calculator up. Alright, so make sure I'm in degree mode, which I am. And then I'll type, the square root of 52 minus 48 times the cosine of 106 degrees. And make sure all of that is inside the square root. Alright, so we're getting side length b here. It looks like in the choices they're rounding to the nearest tenth for all these answers, is about 8.1 units long. About 8.1. Now, when I do future calculations, I am not going to use 8.1. Alright, I'm going to use this value, 8.076545863. I'm going to use this value just to be more accurate. Right, because the more you round throughout a process, the less accurate you get at the end. So I'm going to leave this value up on my screen. Okay. So now that I have found the missing side, little b, I can find one of the two angles. All right, now you could still use the law of cosines, right? Not a problem. Say I want to find, I don't know, what's the larger angle left or the smaller angle left? It really doesn't matter if you're using the law of cosines. So say I want to find, I don't care, what's angle A? All right, say I want to find angle A. Now remember, from the law of cosines, the cosine of angle A would be equal to b squared plus c squared minus a squared, all that divided by 2bc. Right, if you were to set up the law of cosines involving angle A and solving for the cosine of A. So then I would take the inverse cosine, right? So angle A is the inverse cosine of this. Now b squared is the 8.1. Again, I'm not going to use 8.1. I'm going to use the value I have on my calculator. But there's b squared plus c squared minus a squared, all in the numerator. And divided by 2 times b, right, the 8.1, times c times 6, all that in the denominator. Right, so that's seriously how I'm going to enter it. Right, so I got inverse cosine of. I'm going to put parentheses around this numerator. Now, again, instead of 8.1, I'm just going to take this previous answer. So second answer, and that's squared. That's b squared. Plus, 6 squared is 36. Minus 4 squared is 16. Close the parentheses on the numerator. Divided by, and then parentheses around the denominator. 2 times, and then again, instead of 8.1, I'm going to use the previous answer, this 8.076 stuff. Second answer times 6. Right, and then close parentheses on the denominator, close parentheses on the whole inverse cosine, and there. Rounded to the nearest tenth, that's about 28.4 degrees, right? This is an angle. So yeah, you can use the law of cosines, but you could also have used the law of sines. Right, you may see that when you read through some of the answer explanations. You could also use the law of sines now that I have a side-side angle. Right, remember the side-side angle case was one of those cases where you could use the law of sines. But I don't know, I prefer, why not just stick to the law of cosines? I mean, it's just as quick. That didn't take me that long to type in. So this angle here is about 28.4 degrees, and then once you have two angle measures, the third one's no problem. Just subtract these from 180. All right. So now putting these together would give me 134.4. Right, these two together make 134.4, and if I take that away from 180, that'll be what, 45.6. So the angle C should be about 45.6 degrees. And let me just double check real quick. If I add these together, I'll get 74 degrees plus 106 is 180. Right? They should all add up to 180. So we have this, right? Side B was about 8.1 units long. Angle A is about 28.4 degrees, and angle C is about 45.6 degrees. All right. So let's see. And that's the first option here. Great. All right, again, I think they use the law of sines after they find that side B. Yeah, they use the law of sines, but I don't know. It doesn't really matter. You end up with the same result in the end anyway. Just be careful with the law of sines, because the law. Now this angle here already had an obtuse angle in it, 106. So these two other angles can't be obtuse. If you use the law of sines and the angle you're trying to find is obtuse, the law of sines isn't going to give that value to you when you take the inverse sine, right? Inverse sine, the maximum that can give you is 90 degrees. So that's why I'll say be careful with the law of sines, right? Find smaller angles, right? Not the largest one. Find smaller angles with the law of sines if you're going to use the law of sines. But the law of cosines will always work. It'll find you an acute angle, an obtuse angle, right? Because when you take inverse cosine, remember the range for inverse cosine was 0 to 180, right? 0 to pi. So it'll give you any angle, acute or obtuse. So I don't mind sticking to it. All right. So hopefully watching me do this here, looking at more instruction if you need to. reading the answer explanations when they come up. I'm hoping all this stuff helps you out when you go about doing this on your own. And thank you very much for watching.